So the next example is slightly different from the previous in that they didn't give us the initial concentration of the weak base, but they gave us the mass and the volume. So our first step is that we have to convert that into moles per liter. So if we set up our equation to solve for moles per liter of ammonia, we get an initial concentration of 1.30 mole per liter. So this is the initial concentration of the ammonia. The conjugate acid that we form is the ammonium ion, and then we produce hydroxide, so we can assume they'll start at 0. We don't have to include water in our ice table. And we're looking for the pH, so I'm going to have to find the hydroxide concentration first to give me the pOH, and then I can use that to solve for the pH. So if these increase by X amount, this decreases by X amount, and we get 1.30 minus X at equilibrium. So check the rule of 1,000s to double check if we can ignore this change or not. So we have to first find the Kb value for the ammonia. So we know the Ka of the conjugate acid can be found in the data book, and we can use that to solve for the value of ammonia. So if we scroll through the data book, we want to look for ammonia, which is right here. And we're going to take Kw divided by Ka of the conjugate acid. So Kw divided by 5.6 times 10 to the minus 10. So the Kb of ammonia, Kw over Ka, gives us a value of 1.79 times 10 to the minus 5. Okay, if we take the concentration of our weak base, 1.30, divided by the Kb, we get a number that's much greater than 1,000. So we can ignore this change and assume that the equilibrium concentration is 1.30. So now we can set this up to solve for X. So I have Kb equals hydroxide squared divided by concentration of the weak base. And we'll sub in the 1.79 times 10 to the minus 5 equals X squared divided by 1.30. So if we rearrange this to get X, we have square root of our Kb times concentration of the weak base. So my X value is 0.0048. So if we sub that back into our ice table, this is the concentration of the hydroxide ion in moles per liter. And now I can use that to find the pOH, but the question wanted the pH. So we'll take negative log of the hydroxide concentration to give me a pOH of 2.317. So subtract from 14, and we get 11.683 for the pH.